Hi my dear students, in the previous videos we discussed the limit concept. In today's we are going to discuss the derivative topic. Clear? Derivative concept. So this is very important concept my dear students. Please try to understand. So here it is. Let us start derivatives. So why should we study derivatives or what is derivative means? In derivative what we will do? We will calculate how the function f of x changes. How the function f of x changes with respect to x. Clear? So how the function f of x is changing with respect to x at any x you can take here this at the point x. Clear? How the function f of x changes with respect to x, that we are going to calculate in this concept my dear students. So clear? So here it is. First of all, if we will start here it is, if f of x is a any here it is, if f of x is a any real valued function, if f of x is a real valued function, already we discussed what is mean by real valued function. So real valued function means the range of the any given function should be either it is a real number or any subset of the real number, that we discussed in the topic I think second topic, that is relations and functions. In that topic we discussed. Clear? So if f of x is a any real valued function and here it is a is a any point in its is a any point in its domain, my dear students, please observe here it is, if f of x is a real valued function and a is any point in its domain, then we can write here this. Then first we'll denote. How will you denote its domain? Then we denote derivative of, here it is, we denote derivative of f at x is equals to a is. So how to denote my dear students? First we'll understand the notation. Clear? So if f of x is a real valued function and a is any point in its domain, then we denote derivative of f at x is equals to a. What is that one my dear students? We can write here it is, we can write f dash of x, or we can write here it is f dash of a. We are finding at a point, so therefore f dash of a we can write, or we can write df by dx. We'll put like this, and then we will write here it is x is equals to a. So these are all the notations, or we can also write here it is df by dx at a point x is equals to a. So many methods are there, so many notations are there, but generally we will use these notations my dear students. Is it understood? So now what I told here it is, we are calculating in the derivative concept how the function f of x changes with respect to x, how it is changing with respect to x. Clear? So then we will write the definition is denoted by, this is all the notations my dear students. Then actually the function is, the definition of the function is, that is we will denote f dash of a is equals to limit of the function f of a plus h minus f of a whole divided by h as h tends to 0. So this is the definition of the function, derivative of the function f at a point a my dear students. So this is the, and here it is provided limit should exist, provided limit must be exist. So this is the definition my dear students. So what is that one? Please try to understand. First of all, what is derivative? What we are discussing in the derivative? In the derivative we are discussing how the function f of x changes with respect to x, that we are calculating my dear students. Clear? And now if f of x is a any real valued function and a is a any point in its domain, then we denote derivative of f at x is equals to a is, this is the notation. So therefore I wrote here this, and is defined, this is a notation. So and defined, what is the definition? And defined as like this, defined as limit of f of a plus h minus f of a whole divided by h as h tends to 0. So you may have how I derived, how I wrote this one means, my dear students, how I wrote this one means, for this one consider here it is any one curve, any one curve of the given function you can consider here it is. So here I'll take one point, that is x is equals to a point I am going to take here, my dear students. So I am taking one point, x is equals to a. So here it is. Next I'll take another one point very close to a. I am taking another one point very close to a. That point is somewhere here, and this I am taking it as, my dear students, very small quantity I am taking. So this point I will take it as x1. You can take x is equals to this point. Another one point is a plus h I am taking. So try to understand here it is a plus h means this is the point x is equals to a, and the very next to this one, as much as possible, that much very small quantity I am taking, I am adding to this a, means then the next point will be a plus h. So now, my dear students, we know that what is this point on the curve at x is equals to a. This point we can write it as a comma f of a I can write. This point is a comma f of a, because the function a is first a value and f of x is nothing but y value. This is x value, this is y value. We can write f of a. Similarly, we can write this point is x is equals to, here it is, the coordinate is a plus h comma f of a plus h I can write. I hope you are getting, my dear students. So here it is. This point is a plus h, x is equals to a plus h, and the next point is a plus f of a plus h. So these are the coordinates. Now what we are doing, we are calculating. Already I told you that how the function f of x changes with respect to x, that we are discussing. So now here it is, the x is equals to a, this is the point we have, and this is the point on the xy plane, here it is. So this will become a plus f of a. And now another one point is a plus h, f of a plus h. This is the another one coordinate, and this difference is little bit, we increased the h, very small quantity positive value we are taking, h tends to. So therefore, my dear students, we write the definition as the difference where how the function is changing from this point to this point. This is the another one point, this is the one point, how the function is changing. To calculate the change difference we should take. So therefore f of a plus h minus of f of a whole divided by this difference, and this difference we should take, so that we can understand how the value function is changing at particular different x values of x, how the function is changing. That we are discussing in the derivative. Clear? So therefore here it is, we should take first difference of this one, that is f of a plus h minus f of a whole divided by this difference, x difference. So what is this difference, my dear students? This difference is nothing but h, is it? Because here it is a, here it is a plus h, the common difference is nothing but h. So therefore I wrote here it is a, here it is h. So therefore f of a plus h minus f of a whole divided by h. And how much distance we are taking, what is the difference here it is, we increased only as h, very small quantity, h tends to 0, very small quantity we are taking, so that easily we can understanding how the function f of x changes from the point x is equals to a to x is equals to a plus h. So therefore we took here this limit as h tends to 0. We should take very small minute quantity we are taking. So therefore h tends to 0 we took, my dear students. Clear? So therefore this is the definition of the derivative of the function f at a particular point x is equals to, here it is a. And generally this is for the point x is equals to a, and generally at any x we can write this also, we can write it as, so how to write this one means, my dear students, this also we can write it as generally x is f dash of x is equals to limit of f of x plus h minus f of x whole divided by h, here it is whole divided by h, as h tends to 0. So this is the, my dear students, this is the function f of x, derivative of the function f of x at any x. In particular x is equals to a means we will write like this, for any x we can write like this. So remember, this also we can call it as first principle, this also we can call it as first principle, we can call. Clear? So this is also we can call it as first principle. So remember this one, we will discuss further. So based on this we'll discuss further. Clear? So this is all about the derivative. So simply try to understand, my students, what is derivative. Derivative means it is nothing but how the function f of x changes with respect to x, that we are calculating. So this is the first principle we can call. So very very important result, please remember this one. By using this first principle we will discuss some more results we are deriving, my dear students. Clear? That we will discuss later. Please pause the video to note it down. Next, my dear students, as I discussed the first principle. So here it is. What is the first principle? Just only I discussed the first principle of the, we can call that one as the first principle of derivative. So what is the first principle of derivative? First principle of derivative is f dash of x is equals to limit of f of x plus h minus f of x whole divided by h as h tends to 0. So this is the first principle of derivative we can have. As I told, by using this first derivative, we will calculate some more results or some more formulas we are going to derive. So those formulas already are in front of you, my dear students. So for this first we'll discuss cancelled. We are discussing concepts. We should know the only formulas and standard results I am going to discuss here, my dear students. So directly remember these formulas. These formulas are very 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 important. As I told, these formulas are also useful for the second year as well as higher studies. If you go for engineering formulas. Clear? So better please remember all these formulas. These formulas should be in your tip of your tongue. Clear? That much important, these formulas. Clear? So first we'll discuss the derivative of the function f of x is equals to x to the power n. If any function is given to like this, then derivative of this is, notation is f dash of x. Derivative of this is n into x to the power n minus 1. Like that, f of x is equals to x. Nothing is there means we can assume this as 1. Am I clear? So by assuming 1, it means n, in the place of n, if you substitute 1, you will have this result. So in the place of f x to the power 1, apply this formula. So what you will get, my students? X to the power 1 means, what is the formula we have? X to the power n means n into x to the power n minus 1. Like that, 1 into x to the power n minus, in the place of n we have 1 minus 1 into x to the power 1 minus 1 is 0. So 1 into x to the power 0 means 1. 1 into 1 is equals to 1. So this is what I wrote here. Okay. So like this we derive. Similarly, if the function f of x is equals to x square, then f dash of x derivative of this one is 2x. Again by using this formula. And f of x is equals to, if the function is root x, again we use this formula. Root x can be written as root x, we can root x can be written as x to the power. Again in the place of n, substitute half, you will get this results. Similarly, f of x is equals to 1 by x means you will get this result, minus 1 divided by x square. Clear? And if we have 1 divided by x to the power n, you have this one. If the function is trigonometric functions like f of x is equals to sin x, if we have this, then x is equals to cos x. Like that, if the function is cos x, then minus sin x, derivative of cos x is, and tan x means x secant square x, cot x is equals to minus cos x square x. And if the function is sec x, then derivative is sec x into tan x. If the function is cosec x, then the derivative is minus cosec x into cot x. So remember all these formulas, very very important. And please remember, only for the seco, I mean for the cos and for the cot and for the cosec, you have the negative sign. For the remaining all you have positive. Like that you should remember. Clear? So this is all about the standard formulas, my dear students. And please remember, this all we derived from this first principle only. Clear? And next we'll move to the next concept, that is algebra of derivative of functions. So algebra of derivative of function means what? Algebra means as earlier I told, so for operations whatever we used, that how to apply in the different cases. In complex number also we discussed how to add the two complex numbers, clear, like that. So like that here also how the derivative of the two functions, how to add the derivative, that's why how to add subtraction and multiplication and divide. So this is all about, so we are studying under the algebra of a derivative of the function. So for this also we have the formulas. If the given function you have, say for example f of x, if you have the two functions means f of x plus g of x, if you have the two functions, how to find out the derivative means by using this formula. What is the formula? Derivative of here is f of x plus g of x. So derivative of f of x plus g of x, two functions derivative if you want means you should use this rule. What is that? If you wanted to calculate, say for example, if I have the two functions f of x and g of x, if I wanted to calculate the derivative of this means, what should I do? If I wanted to calculate derivative of this means, what I'll do, I'll take derivative of first here this derivative of this function plus derivative of this function, that is g of x. Like this we calculate. This is what of f of x plus g of x is nothing but derivative of first f of x plus derivative of g of x. Similarly, like subtraction also, if you wanted to calculate the derivative of here it is f of x minus g of x means, how to calculate? If we have the two functions f of x minus g of x, if you wanted to calculate the derivative of this means, how to write? Derivative of f of x minus derivative of g of x. Like this you can write, clear. So this is what I merged these two plus and minus. For that reason I wrote plus and subtraction. If it is minus means we should put minus, clear. Of writing different these two formulas, I merged and write plus or minus here also, plus or minus. It means for the positive, for the addition and subtraction, this will valid this formula, clear. Like that, if you have functions, say for example f of x and g of x, if I have the two function f of x and g of x, if I have the two functions, if I wanted to calculate the derivative of these two functions, if I wanted to calculate the derivative of these two functions means we should use product rule. So product rule, what is product rule? We have here product rule I given to you. So what is that one? Derivative of f of x into g of x. If we have two functions, if you wanted to calculate derivative of those two product means, in that case use the product rule. What is product rule? This is the product rule. The product rule is, here it is derivative of first function into second function g of x as it is, plus here it is first function as it is, now second function derivative of the second function you can write, clear. So this is the formula, this we can call it as product rule. Please remember this formula, very important. You can write like this, or you can also write, my dear students, derivative of u into v. Instead of writing every time f of x and g of x, in short I can write f of x, you can take it as u, and g of x you can take it as v. To remember the formulas easily, what we will do, my students, either you can write like this, or you can write first function as it is, derivative of second. You can write first function as it is, derivative of second, we will write that as v dash. First function as it is, derivative of second, plus second function as it is into derivative of the first function. This is also valid, either you can write like this or you can write like this. Here what I did, f of x and g of x I used, and another one concept is, here first only I took the derivative of the first function, clear, and here I took the second function derivative, but here what I did, first function I wrote as it is, then I took the derivative of the second. So usually I'll use this one only, my students. So what is the product rule? You can call, both are same. Instead of writing f of x and g of x, I took u and v, clear. So derivative of u into v, first function as it is, derivative of second, plus second function as it is, derivative of first. This is, we can call it as the product rule, clear. And next one, my dear students, division, quotient. This rule we can call it as quotient rule. If you have the two functions in this form u by v, If you have this condition means how to calculate the derivative of this one? Derivative of this one is, here it is denominator v into derivative of numerator du by dx minus numerator as it is derivative denominator dv by dx whole divided by denominator whole square. So this is this we can call it as quotient rule. If you have the two functions in this form u by v, if you wanted to calculate the derivative of this means you should use the quotient rule. You should remember all this. Clear? So what is the quotient rule? So denominator whatever we have v into derivative of numerator minus numerator as it is derivative of the denominator whole divided by denominator whole square. So this we can call it as quotient rule. Clear? So all these concepts, all these formulas are very very important. Please write this one and remember all these formulas. Clear? So now please pause the video to note it down, and next we'll discuss the questions based on these formulas. Clear? So please pause the video to note it down. Yes, my dear students, already I wrote the questions. So we'll solve the questions based on these derivatives we are solving here this. So the first questions, my dear students, I am going to discuss the answer for the first question. So find the derivative of x square minus 2 at the point x is equals to 0. So to solve this one, let us take the given function as y is equals to square minus 2. Take the function as y. Let y is equals to x square minus 1. Now they asked you to find the derivative. So derivative, differentiating with respect to x, that is nothing but derivative itself. So differentiating with respect to x, so write dy by dx. So derivative of this function dy, we will write y as dy by dx, y differentiating with respect to x. So therefore I will write dy by dx. So x. So what is the derivative of x square, my dear students? Derivative of x square, already I told you. Even the derivative of x square. And derivative of this constant v, dy by x, derivative of 2 is we have the result x to the power n, the derivative of the function x to the power n. What is the formula we have? N into x to the power n minus 1. In n we have 2, here it is. So again apply this formula. So what is the formula? X to the power n means n into x to the power n minus 1 is 2 to the 2 minus 1. In place of n here we have 2. So therefore 2x to the power minus 1 is, that is nothing but, therefore derivative of x square is 2x and derivative of any constant is 0. I didn't give you this result, so please write down this result. What is that one? Constant is equals to 0. Derivative of any constant is equals to 0. Please make this formula to the formula list. Understood? Therefore the answer is y by dx is equals to 2x. So they also asked you to calculate the derivative function point x is equal to 0. It means first you should calculate the derivative. So we know that derivative y by dx is equals to 2x. We should calculate at x is equals to, at x is equals to, we should substitute, calculate the derivative to 0 means substitute x value as 0 is equals to 0. So this implies dy by dx is equals to 2 into, put x value as 0. So 2 into 0 equals to 0. So therefore derivative of the given function at a point x is equals to 0 is equals to 0. Clear? So like this you can write. So this is the answer for the first question. Next I am going to solve the second one, my dear students. So for the second question, the answer is, again take this function. Let y is equals to, what is the function? 2 into x to the power 4 plus x. So here it is differentiating derivative, dy by dx is equals to 2 is a constant, keep as it is, 2 into, here it is x to the power 4, x to the power 4 derivative is 3 into x to the power, 4 into x to the power, clear, and plus derivative of this plus derivative of x is equal to 1. Clear? How many? I think another one formula I didn't give you. Please add the formula. Derivative is equal to derivative of the constant. Clear? So k is a constant, means you should take outside, and remaining functions derivative. Please add this formula also. Please add to your list this formula also, and this one also add. If I didn't give the formula list, means add this also. Clear? So my dear students, so x to the power 4 is, I am applying this result, so that is 4 into 1. So therefore dy by dx is equals to 4 into 2 is 8 x cube plus 1. So this is what your required answer for the second question. Understood? And next one, my dear students, third one. So answer for the third one. So what is the third question? Here it is x cube. So let us take, let y is equals to x cube. Now calculate the derivative of this one. Dy by dx is equals to 3 into x square. This is the answer. Why it is so? Why it is so means x to the power n. What is the formula we have? X to the power n. Derivative of x to the power n is equals to n into x to the power n minus 1. So like that, the derivative of x2 cube, so n place of n, substitute n value as 3. So therefore 3 into x to the power 3 minus 1, 3 into x square, 3 minus 1 is 2. So therefore 3x square. Clear? So this is the third question. And next we will solve the fourth one. Clear? So please pause the video to note it down. Next I will solve the fourth one. Yes. Now we'll solve the fourth question, my dear students. So what is the fourth question here? It is, so fourth question is, find the derivative of x to the power 5 minus cos x whole divided by sin x with respect to x. To calculate this one, so already I told you that we are going to use the quotient rule. So what is the quotient rule, my dear students? Quotient rule, I told you that if the given function is in the form of u by v, if we have like this, we should use this quotient rule. So what is the quotient rule? Denominator as it is, derivative of numerator, that is we can write like this. So derivative of u, clear, denominator as it is derivative of numerator minus numerator as it is derivative of denominator, you can write dv by dx also, whole divided by denominator whole square. So this is the quotient rule, my dear students. So this I am going to apply here. This. So first of all, let us take, let y is equals to x to the power 5 minus cos x whole divided by sin x. So the given function is like this. So now differentiate means derivative. So dy by dx, take here this, both sides we are applying the derivative. So y, if we differentiate means dy by dx. So dy by dx is equals to, here it is, what is the formula we have, my dear students? The formula is denominator as it is sin x, denominator as it is, and derivative of numerator d by dx. With respect to x means you should write dx. So denominator as it is, derivative of numerator. What is the numerator? X to the power 5 minus cos x. Denominator as it is, derivative of numerator minus numerator as it is, x to the power 5 cos x. Numerator as it is, derivative of the denominator. So what is the denominator? Sin x whole divided by denominator whole square. Clear? So denominator as it is, derivative of numerator minus numerator as it is, derivative of the denominator. Now simplify this one further. So therefore dy by dx is equals to sin x as it is. Now we should calculate derivative of this. So what is the derivative of this, my dear students? First we will calculate derivative of this minus derivative of this I am going to write. So derivative of x to the power 5. X to the power 5 is nothing but the derivative of x to the power 5. So d by dx of x to the power 5 I can write it as x to the power, and if you apply means n into x to the power n minus 1. So 5 into x to the power 5 minus 1 is 4. Clear? So therefore derivative of x to the power 5 is 5 into x to the power 4. And next, my students, minus as it is. What is the derivative of cos x? Direct formula we have, derivative of cos x is minus sin x. Am I clear? And next, minus as it is. This is as it is. The function minus of this function is as it is. X to the power 5 into cos x. Now, derivative of sin x. Directly we have the formula. Derivative of sin x is cos x whole divided by sin x whole square, means I can write it as sin square x. I can write. Just I applied this quotient rule. We'll further simplify, my dear students. So further simplify that one. If you further simplify means you can write it as sin x into, take this sin x inside the bracket, sin x into 5 into x to the power 4. So that I can write it as dy by dx is equals to 5 into x to the power 4 into sin x, minus minus it is plus, sin x into sin x is sin square x, minus x. This is all we simplified. So next, minus into x to the power 5, x to the power 5 into cos x, that is minus x to the power 5 cos x. Next, minus plus minus plus. Next, cos x into cos x is cos square x whole divided by sin square x. And now here it is dy by dx is equals to 5 into x to the power 4 sin x minus, I will write first this one, next this one. So x to the power 5 into cos x plus, I will write this one, sin square x plus cos square x whole divided by sin square x. My dear students, just I rearrange the terms. What is that one? I wrote first this one, and next I write this and this one. All the terms are there only, just I rearranging the terms. Clear? So now, my dear students, dy by dx is equals to 5 into x to the power 4 sin x minus of x to the power 5 into cos x plus 1 whole divided by sin square x. This is your required answer. So why I wrote this as 1, my dear students? I wrote this as 1 because already we know that since sin square x plus cos square x equals to 1, this we learned in the 10th classes, is it? That is what I applied. So sin square x plus cos square x value is 1. This I wrote. Like this you should solve, my dear students. Try to solve some more questions based on this one, but every question is a similar type of questions, so please try to work out those questions. Still, if you have any doubts, you can comment me. I'll reply for that. Clear? And in the next, this completes your limits and derivatives. In the next video, we are going to discuss the next topic. Clear? So please pause the video to note it down. Thank you.